Hey, Richard George, welcome to the Guild.
Hey, Joe, great to be here.
Awesome.
Hey, Joe, good to see you.
Good to see you too. And like I said, in LinkedIn alone, all the comments, people are really excited about this session, especially excited to learn more about model-based testing. I don't know if there's some things out there that aren't accurate or there's not a lot of information out there. So really excited to have you all just show us and let us know like how this can help us.
Cool.
So the floor is all yours, Rich. I don't know if you're going to share your screen. And like I said, I'll be asking the question. If there's any questions that come in, I'll probably interrupt at the right place to get in for you.
Yeah. Just set myself up so I can actually see something.
Yep, looks good.
Okay, cool. So thanks for the introduction, Joe. Really great to be here, everybody. My name's Rich. I'm going to take you through the first half of this session, which is really about kind of setting the scene, talking through some of the challenges you would inevitably have had as a test team, trying to get automation working. But actually, we're going to touch on some more kind of systemic organizational problems that you've probably got, which are impeding both test automation, but also testing in general. Okay. And then in the second half, we're going to hand over to the much more interesting part, which is George talking you through implementing some of the things that I'm talking about within our tool, which is Modeler. Okay. So without further ado, we'll get started with a quick introduction to test automation. So really, automation kind of dominates the kind of testing industry when it comes to the things we talk about, industry analysis. To be honest, what our stakeholders and organizations want, right? Everybody aspires to automate all of the testing, all right? But for something that's had so much focus over the past couple of decades, really, the analysis suggests we're not that great at it, right? And as Joe mentioned earlier on, the analysis, and we're talking about the World Quality Report here, suggests that the automation numbers equate for only 15 to 20% of testing that we do. There's an implied assumption there that we're talking about execution of automation, or I should say test execution, rather than everything being automated, but we'll run with it. Okay, and part of that as well, regression, which historically you kind of think is the bedrock of opportunity for things to be automated. Again, that sits at the 15 to 20% band, which is not great. So hopefully during this next hour, we'll kind of tantalize your kind of thought process and show you some things within the tool that will hopefully help you face into some of those challenges and not only make your automation numbers a bit better, because it's not just about automation numbers, but actually make your testing a bit better as well. All right. So let's get started with an early poll. And the poll is really trying to gauge the kind of the level of automation that the audience that we've got today. So really, this is where I might have to defer to Joe on this one in terms of how it actually works. But the poll question we'd like to ask is, what is the rate of test automation at your organization?
Absolutely. And to answer that poll, the poll is now live under the Q&A tab. So all you need to do is go to that Q&A tab. The poll is right there for you. Let us know, what is the rate of test automation at your organization? And get those, because I'm curious to know, and I'm sure I'd like to know how we rate, the Guild rates against other industries and other folks that Curiosity has spoken with. So give a good showing here. What is the rate of test automation at your organization? All right, some polls are coming in. Let's I guess we can watch it all live together.
You can be honest, by the way.
All right. So 20 voted, 21 voted so far. All right, seems to be dying down. So it looks like higher than 15 to 20% at 35. And the next is lower than 15 to 20%. All right. Polls still coming in.
Yeah, a real mix, isn't it, Rich?
Yeah, for real.
Cool. Yeah.
Yeah.
So is this normal? What you normally see?
Cool. It is. I think where, obviously, the audience is an engaged test automation crowd, right? And
Yes.
therefore, if I were a betting man before this, I would have said, kind of we might see a larger proportion of people coming in at the higher rate. But I think it's interesting, right? In that we're seeing the teams, even teams engaged in the conversation of automation, are really struggling, right? And therefore,
Yes.
there's some real challenges there, which is good.
Yeah. No, it's a good point. Whenever I surveyed the audience, they say they have between 5 to 15 years of experience. So, and they're at 40%, 39%. So that's a good point. People are still struggling, even as experts in the industry. So good point.
Cool. So we're going to try and kind of unpack that now to give you hopefully some helpful tips in terms of how you can get kind of your automation working a little better, but also your testing a little better as well. So we're going to talk about some of the challenges that teams see now. I think as I go through this, obviously the numbers are useful in terms of understanding the maturity of the teams. But I think even where, and I've worked in teams that have got automation ratios that are in the 80, 90%, they're still seeing these challenges, right? And I think the interesting part, or the kind of the mindset shift that we need to go through, is that actually creating an environment for good testing and good automation is an evolving beast, right? And you've got to stick on top of it. So what are some of the things that teams are struggling with? Well, the reality is that they're struggling because a lot of the time they're just trying to automate what they're doing already. All right. And, this is one of the reasons why, confession, I don't really like that question that we just asked, right? I appreciate the irony that we actually asked this question. But I think the challenge in the question alone is, or the interpretation is, it doesn't provide any context, right? And the outcome is, we'll just automate more then, right? But that's a problem, because we've already tried to do that and it just doesn't work. So what are the problems that we see some of the teams facing? Okay, so actually, and these are more kind of fundamental testing problems, in that we've got bloated regression packs. All right, so as and when teams work on a system and they go through iterations and iterations, the pack just grows and grows and grows and grows and grows. All right, and therefore the automation burden or the testing burden becomes ever more increasing. All right, and that's a problem for creating just-in-time test automation, but also robust, stable automation. Okay. We test too much at the UI. We all know, right? The testing pyramid, the UI is the hardest place to try and get stable, robust automation, right? We've got to do some there, but actually too much of it is still centered around the UI. And also, carrying on the pyramid theme, too much of it is end-to-end, right? Again, it's hardest to try and test through the UI, but it's also hardest to try and string together lots of end-to-end environments to create a stable platform that allows us to be effective when we come to automation, all right? And what we're really talking about here is actually injecting a lot of accidental complexity into our testing process, right? Or you could see overall our development process, right? Because we're doing so much end-to-end testing, for example, we've got combinatorial explosions. All right. So if I go from one system and jump to an interface to another system, I'm multiplying out test cases for one system by the test cases for an interface by the test cases for another system, right? So I've just got a massive, massive explosion in terms of the amount of testing I need to do to try and get a level of coverage, right? And it's doomed to failure, all right? Because that level of explosion is just going to carry on growing as I add more features to my change process, all right? Coupled with that, we've got huge data requirements. I need to string together lots of environments, and therefore I need lots of data requirements to satisfy where those data sits, but all that combinatorial explosion. But also I've got that large test environment requirement, all right? So not only have I got this massive accidental complexity, but it's extremely slow and expensive to actually stand up all this infrastructure, basically because I've chosen the approach that I've got for various reasons in the way that I'm going to test, okay? What we also see in this is, because you're kind of trying to catch up in terms of test coverage, you need to get your test outcome reports, for example, out the door by the time the sprint finishes. You're going to take shortcuts, right? And therefore, you're going to add another, you've got a test pack of 100 test cases, you're going to add another 10 for new features. And by implication of that, what you're going to start to do is create duplication in the coverage you've got, right? You've got tests that kind of already cover those kind of paths. you start to build in duplication and duplicated effort in top of that, right? So you've got a lot of accidental complexity that you're building into your processes today. What you've also got, and we don't talk about this quite so often, is you also tend to have, especially where you've got static understandings of the system. By that we might mean test cases, for example, or we might even mean automation of test cases. You get a separation of what the test case is doing, but also what the system is doing. All right. And that really feeds into that accidental complexity where we don't have intrinsic links to test automation asset to what the system is doing. There is a gradual separation. All right. We're going to come on to this in a bit more, in a bit of a theory around kind of managing that complexity. All right. Fundamentally, by carrying on doing the same thing but trying to automate it, you kind of got this analogy that everything if all you've got is a hammer, everything is a nail, right? And actually we need to change up what we're doing in terms of our toolbox of approaching testing. Okay, so I've kind of touched on it quite a bit, but we're going to touch on it a bit more. But we're really talking here fundamentally about creating the right conditions for test automation or testing in general, right? And what we're talking about automation, we're talking about industrialization, right? And therefore, you need to do standardization, right? You need to make things known, you need to describe them, they need to be predictable, and they need to be repeatable, right? When we touch on this diagram, people might be familiar with the Cynefin framework. The framework really is there. It's a Welsh word that means habitat. It's there to help people make sense or make decisions within organizations, for example, around levels of complexity within systems. Okay, now I think this is a great picture in terms of trying to articulate the problem or the challenge that I think testers have got when they're trying to understand a system, make it stable enough and repeatable enough to create the assets to be able to create automation. And you might see this diagram as a bit of a stepping stone up the level of maturity to get to, at the very top, you can see there, you've got a little pedestal, which is automation, all right? And therefore, a lot of what we're talking about here is creating the right environment to allow you to have stability, predictability, and reusability to get automation going, all right? Now, the problem with creating this habitat is that as well as creating this stability, change happens, right? And the problem with change is that it creates systems entropy or software entropy, I should say, all right? And as we all know, right, change creates a problem for understanding what's the impact of that change, right? And when we're talking about software entropy, we're talking about the measure of chaos that we're introducing by making each change, all right? And in the same way that we can go up that step ladder of Cynefin, we can also come down in terms of introducing more complexity and therefore chaos into our understanding of the system. And that feeds into our understanding of the testing and therefore our ability to do automation, right? And we've talked about some of the symptoms of that in the previous slide when we talked about things like test bloat, right? And we talked about things like accidental complexity, all right? And a lot of the time, these things happen because actually our understanding of what the system is doing, how the system is changing, and how we're supposed to test it isn't quite as good as it needs to be because actually we're dealing with static artifacts today or our understanding of how that system works, right? So how do we face into software entropy? All right, there's two real ways. We improve communication in our team and we maintain coherence with product standards and established design principles. All right, and we're going to touch on these two things in a second. And this is really where kind of modeling comes to the fore in terms of how we start to use modeling to understand how our system works, but also how it changes and how we can use those artifacts and assets to create the testing automation outcomes that we aspire to, okay? So firstly, we're going to talk about improving communication, all right? So by that, we don't just mean talk better to your team. Actually, we're talking about creating structured communication within the team or to other teams to make sure that we have got a collective understanding of what we're trying to do, right? By its very nature, software development is emergent and therefore it's changing, right? Should we expect to have a fully grown set of requirements? Well, of course not, right? And we never will, is the reality. And therefore, what we need to do is put in a process, and things like BDD and the Three Amigos is great for this, to have early conversations. And what we're talking about here is shift left when we're talking about testing, to have early conversations about understanding how the system works, how the system is supposed to be changing, and what's the impact of that, right? And what you can do, and what we would suggest you do, is put modeling at the very heart of those conversations, all right? So when you're having that conversation, you're creating visual representations or prototypes or wireframes of how you want your system to work, your interface to work, any number of things to understand and get a collective understanding. And I can't underestimate the power of that collective understanding to remove issues and defects when we're talking about creating those early understandings of how that system is supposed to work, all right? Another important thing, and this is to the systems entropy or software entropy point, is touching on having robust conversations early on about the parts of the system or the parts of the organization that we really do not understand, all right? And it's inevitable that will be the case, right? Especially if you've not worked or been conscious of technical debt or entropy in the past. No doubt we're all sat here thinking, yeah, I know our understanding of that interface or that third party isn't great, right? And we would love to have this kind of engagement with other teams to build out wireframes to get a better understanding of how that thing should work so we could test it. All right. Now, what we're essentially doing by having these Three Amigos conversations, creating these models, is creating that articulation of how the system should work. We're creating the repetition, the predictable outcome. Actually, we're creating the bedrock for good test automation. Yeah, that's great. We've improved communication. We can't stop there, right? If we just stop there, we've still got a few problems. We could still create the wrong types of tests. There's nothing to stop us doing this Three Amigos conversation and creating lots of end-to-end tests, right? And we know that's not the case because we're going to create lots of incidental complexity if we do that, all right? So we've got to go to the other part of the entropy, facing into entropy, which is aligning to best practices and product design, all right? What I flashed up here is a kind of bringing up synergies with development processes. And what we're talking about here is the 3 ways of DevOps, for example. And to bring synergy on what I've just been saying, what we're talking about here is always seeking to achieve profound understanding of the system and always seeking to increase flow, right? So what we're really talking about here is embedding best practices, but not just in testing, but in the whole life cycle of development, right? Testing is not an island anymore. We need to incorporate ourselves into that full development life cycle. This is just one example of how you could go and do that, right? Stretching on a bit further into test approaches and how modeling can fit into those test approaches. I've mentioned the pyramid quite often. I think one of the challenges is although we know the test pyramid is good practice, actually we're locked into current approaches, right? Or we're locked into not adopting the test pyramid. For example, we don't have the API exposed to us, or we don't have a good enough documentation set around how that API should work, and therefore that barrier prevents us from incorporating the test pyramid, and it sticks us with slow, clunky end-to-end testing or UI testing or things like that. It's a real problem. So what can we do? Actually, this is where we can model the world, right? And what we're doing really here is breaking out the systems architecture, in creating isolation around that systems architecture to articulate the various aspects of what we can model, and implementing the test pyramid in an effective way. And you'll see from here that actually we're going beyond the test pyramid here, and we're talking about things like compliance as code. When we're talking about platforms, you can model that as well, right? And we're really creating a good engineered understanding through our Three Amigos conversation of how our systems architecture actually works, right? The good thing about this is you don't need the full architecture to be there. In fact, you don't need any of it to be there. You can start to build these things out from scratch. And as you start to add and bolt on new parts of the systems architecture, you can start to build that picture up, and you replace virtualization with real things, prove things in isolation. This is really about creating isolation in what we're trying to do here, right? And again, what we're doing is building synergy with design practices around loose coupling, which you'll find a lot in architecture. All right. Conversely, I mentioned some of the time we don't know how our APIs work, for example. what this is looking to do is, on the reverse of kind of building things up from the ground up, actually, we can start to use the strangler pattern where we don't know certain parts of our systems architecture, for example. So if I don't know how my interface to my third party works, we can have our Three Amigos conversation, understand that's the case, start building out an API model with our Three Amigos, with our third party Three Amigos, and then we'll build out a model API of how we think our system works, and we can start to prove that with some robust conversations, design conversations, but we can also build up a very early API test infrastructure to create a CI pipeline, if you like, to create continuous integration with them, so we can improve our understanding of how that interface actually works. Right? This is an emergent practice. Our model can build out and out and out and out and out. All right. To try and bring some reality to what I've just been saying, this is a real architecture diagram where we've started to draw out test types to create isolation and really create a continuous testing approach based on what is, on the face of it, a monolithic architecture. All right. And what we're talking about here is really aligning to agile ways of working, agile with a little a, so we can be nimble in terms of reacting to change, but also, and I'll cast your mind back to the DevOps ways of working, allowing the team to experiment in a risk-averse way. All right. What we're talking about here again is limiting the blast radius. So if something goes wrong, it's going wrong in isolation, right? So we can look at that. We can get fast feedback. It's targeted feedback. Our whole end-to-end system environment hasn't fallen on its bum, right? And we don't have to wait weeks and weeks and weeks for it to be rebuilt. What we're talking about here is fine-grained feedback, small systems, small data. Everything is small. Cool. So we understand entropy. We understand how to face into that. We're having really good Three Amigos conversations where we're building models. We've got a test approach where we've broken these things up into nice, fine-grained understanding of our systems architecture. That's great at the macro kind of test approach level. How can modeling come to life in terms of the micro levels? All right, change is happening, right? It would be great if we could put all these things in place and nothing ever changed, but that's not the reality, right? Our systems or our test approach needs to be built for change, all right? And really, this is where test modeling comes into its own in terms of, at this point, making the model work for you rather than you having to work to update the model, right? If you've got static Visio diagrams, for example, or test cases, you're going to get that drift I mentioned earlier on, right? But modeling or living specification, as I've called it on here, does a lot of the grunt work for you, right? And it gives you insights that without this approach, you just wouldn't have, all right? So what kind of things does it do? It allows you to understand the impact of change, right? I've touched on it quite a lot, right? In that if you want to understand kind of, I've got this system that interfaces with a third party. That third party might make some change. How can I understand the change they're going to make and what impact it's going to have on my internal systems, right? Well, I can model that out and I can make those changes to my wireframes in my Three Amigos conversation, and I can understand where that impact of change is impacting me rather than having to go right the way through the development lifecycle and then finding that in an end-to-end scenario. All right, you don't need to do that. Okay, how can I prevent test bloat? Yeah, we've mentioned, as ways of working, we just bolt on another 100 tests to my already massive test pack, and my burden of maintenance just grows and grows and grows. With modeling, what we can do is we can make the change to our model to reflect the system that we're working on, and actually refactor our test cases in real time, aligned with how the system should be working, i.e. the model, and that gives me a nice refactored articulation of the test pack, all right? The same goes for my test automation assets, right? I want to minimize my my maintenance as much as I can. And again, Modeler allows me to do that in terms of aligning my test automation code to my model blocks. And as those model blocks are changing, I will know that my automation is also changing, and I can refactor and maintain my test automation assets accordingly, all right? How can I guarantee that I've got the correct data for test execution? Well, again, similar to automation assets, my data is linked intrinsically to my data, my process block in my model. And so I have the business rule in the model. I can align my data one-to-one with that model, so I know I'm going to have confidence that it's there when I want to execute my tests, so my tests don't fall over for flaky reasons that the data is just not there. And then how do I get maximum coverage for minimum effort? And again, this is where Modeler allows me to use optimization techniques to essentially generate the the minimum number of test cases, I should say, to achieve the maximum amount of coverage to exercise my system, all right? And what I can start to do on top of that is apply coverage techniques and start to talk about coverage techniques in the way that I'm articulating the depth of testing that the team have achieved. But I could also start to apply risk-based techniques, change my teeth, techniques, when I have considerations about extremely sensitive areas of the system or things that have gone wrong in the system. All right, I can target my optimization accordingly based on that. All right, so that is a very whistle-stop tour in terms of what are the challenges some of the test teams will face, what's kind of entropy that happens that people probably don't or aren't conscious of, but everybody knows is there, and then how can modeling help you both from a macro test approach level and a micro test approach level, stay on top of all of that requirement for change. All right. That's a bit enough about the theory. What I'm going to do now is hand you over to George, who's going to take you through the practical. Over to you, George.
Great. Yeah. Thanks very much, Rich. So yeah, basically what I'm going to run through is pretty much what Rich went through there. So I'll just share my screen quickly just so we can get started. So what we'll be looking at in this kind of example is essentially an e-commerce store. So we're all pretty familiar with what an e-commerce store can do and sort of the different components throughout it, right? As we go through, for example, on our model canvas, we have things like sort of opening the web page. We've got sign up, we've got login components. As we continue on, we're considering then adding some kind of product, talking about sort of sizes and quantity, and then eventually checking out and then getting a particular status of the order that I will have just added into our system. Now, this is a very, very high level kind of bird's eye view of what's actually happening in your application. So as Rich was mentioning there, this model kind of becomes the living documentation that you guys will need to sort of maintain and keep all of your assets up to date. So let me dive a little bit into some of the details here, just about how this all works. So obviously these are all kind of single blocks on our application, but as we go in, we can kind of expand these and get a bit more of an understanding of some of the business rules and some of the logic that actually exists within our system. So, for example, I expanded our subflow here called sizing and quantity. Now, if we take a closer look, what we'll see is that inside of our e-commerce website, we've got a series of different sizes and a series of different quantities and colors that we can apply to each of our products that we're selecting. Now, even by doing this is giving the opportunity to capture some of the rules and some of the logic in, I guess, a resource that is understandable by everyone, right? Instead of having that rule captured in a 500-page Word document or hidden in a Confluence page, you can have it in a visual flow, right? And you can begin to understand, okay, well, I can have these different options when I'm adding a particular product to the store. Now, underneath here, it's not just a visual map of what's going on. We also have the ability to overlay test data and overlay test automation onto these models. So if I come in here and take a closer look, we have underneath these blue waypoints, we have a series of automation references. Now, these automation references are essentially code snippets that have been overlaid on top of our model. In this instance, this code snippet has actually come from our web scanner. So on the application, so this is the example app that we were looking at, we can come through and, similarly to other styles of scanners that are out there, we can come through and begin to pick up the different buttons and the different elements that exist on our web page. Once we've gone through all of those, we can come in and actually upload those into our workspace. So, for example, if I come into the main menus here, I'm just going to click on our Magento login and go to the page collection, which is associated to our login and sign up screens. Inside here, there are a series of page objects that we scan with, not only just the first name or the class name, but also some of the identifiers underneath them as well. So as part of that scanning process, we're picking up identifiers, whether it's XPath, CSS selectors, whether you need to use iframes, for example, or shadow DOM elements. Those are all configurable with that scanning process. And essentially now what we do is we create a module collection from those objects. So taking a step back, how test automation in general works with Test Modeler is that it is all kind of template based. So what I mean by that is that inside of the tool, we have a series of templates that we can use to generate code automatically. So for example, if I scroll down and select maybe this click create an account, if I come in and take a look at the code, you'll see here that we've actually generated sort of 25 lines of Java code for our click create an account button. Now, this is the example where I've used Java. In Test Modeler, it really doesn't matter. It's whatever template you can write to fit the code generation within your practices or ways of working. And essentially now what you can kind of think of is, okay, well, we've got this code snippet, and now what we're doing is we're essentially overlaying this on top of our model. Now, obviously with automation, it's not just a case of overlaying code snippets and moving them about. Some of those code snippets will also have parameters. So for one of these, for example, I have the enter quantity here. This function has an associated parameter. So obviously, when you're buying a product, you need to tell the system how many of that product that you want to buy. What we've done before this is set up a bit of a decision tree in here, where we've got a few different options for how many products or how many items we want to buy. Now, the few options I put in here, so few, some, or many, right? And essentially what's happened here is we've been able to apply a data generation function that will go away and in this instance will randomly generate a number for me between 0 and 2. I can hit preview result and that will go away and essentially resolve that function for you. The advantage of that, as Rich was talking about, is that you can now, at the same time as you're generating your test cases, resolve these test data functions and get the test data in the right place at the right time. You're not now relying on a call out to, an Excel spreadsheet or some other repository of test data where, that test data might now be out of date. For example, another tester might have come in, they may have run 200, 300 UI tests or API tests, and they've used your data. That's going to be stepping on each other's toes. The advantage here is that we are generating that data on the fly and allows you to populate your automation scripts pretty much automatically. So for few, I've done between 0 and 2. For some, 2 and 3, many, 3 and 4, for example. And so that kind of covers sort of how these models work. There's, I guess on top of this as well, you can overlay manual test logic as well. So these models are not just for generating test automation. We can come in and overlay things like summaries, descriptions, and expected results on these blocks as well to give a bit more of an understanding of what these models are doing and what sort of features that they're testing. So let me take another step back, and again we'll go back to sort of something that Rich was talking about, in that so much of testing is really focused on the UI. Whereas, you can do pretty much the same or a better job by running those tests through the back end or through the API. So these components at the moment they're all sort of web-based testing, but this one at the end is for our get order status. So essentially in this workflow, what we're doing is we're buying a product, then we, at the very end, we're scraping the value for what the order number that we have. And then what we've actually done is set up a little function inside of here that's going to go away and actually get that order status. So you'll see inside of Test Modeler, we have the ability to embed sort of an API request. And inside this, we're specifying the URL. We're going to go get something, and then we're capturing the response of that. We're capturing the response here. So we're pulling out, in this instance, the status. So actually, this is becoming more of a cross-platform example. We're not just now focusing on UI tests. We're also expanding and beginning to focus more on integrating API components as well. I mean, typically what I've seen a lot while I've been at Curiosity is the ability to embed API components throughout these workflows. So, a good example might be, for example, if you've got a CRM application, you could have 2 or 3 of these components here that are UI based. But then you could have something like, oh, okay, I want to create a new person or create a new lead via the API. Integrate that within your model, and then that person that you've created through the API can then be used throughout. So, you have your web components up here, and then sort of your API components down at the bottom here. And then you get the ability to kind of create a map of what is happening in your application. This then becomes kind of living documentation, because then you can say, okay, well, what if I change something in this flow? What impact is that going to have? Immediately, by looking at this model, I can see, well, there's going to be some kind of direct impact to perhaps the next flow, sizing and quantity. And then if we think downstream, okay, what if something changes that the checkout flow needs from inside of the woman product flow? Whereas, without a model-based approach or without a visual kind of cue, it's going to be pretty difficult to fully understand what that problem is. For the system experts, they might be able to figure that one out. But for anyone who isn't, in the code day in, day out, isn't a product owner, for example, then, they're not going to really understand. So having a visual diagram is a really good approach. Okay, so what can we actually do with this model now that we built it? So what I just did before we came on air is actually come through and generate some paths. So in this instance, I have created 16 paths through the application. Now, if I scroll through some of these, I'll just sort of go for a high level view, just so you can see. But as we scroll through, you'll see that we're kind of picking out different scenarios and different combinations of behaviors on that web page. And as we go through, that path generation is picking out different edge cases, different nodes, and each of one of these paths is now, in essence, its own test case. If I zoom in, you'll actually see, for example, Magento Web Store 11 has 79 associated steps with it. I can come in, take a look at those steps myself. These are essentially your manual test cases. But most critically, we can actually come through and run some of those test cases as well. So what I did just before this is use that Java Selenium-based framework to actually go away and run those test cases. So I can come in here, click on the eyeball button, and this will basically bring up some information about what happens during that run. So for example, the first step is, okay, we're going to load the web page. Then we're going to go through and we're clicking on our create an account screen. That takes us through to here. We go through, we enter all sorts of data. So these are all dynamically generated functions. So first name, last name, email, for example. We scroll down, you'll see that one of the data generation functions for quantity resolved. It gave us 3 in this instance. And as we go through, you'll see that, okay, if we click on here, we've added this particular jacket to the shopping cart. And as we continue to go through, we eventually get through to the end point of saying, yeah, thank you for your purchase. Now, it's all very well and good me showing you sort of 16 parts already generated, but we do need to consider how those parts have been created. So Rich mentioned it previously, but essentially what we do is we run kind of an optimization that generates the minimum number of tests required to meet your specified level of coverage. So what I've done is I've just prepared a few different sets of test cases. So I guess a bit of just so you guys understand, we've split these out into error cases, so kind of negative test cases, and then successful or positive test cases. So for example, for my success one here, I've set a high coverage setting. That's created us 16 parts. For example, then I've also, for the same success, I've created 9 parts. And you'll see here that, we've got almost like a multi-purpose model. We can create a very slimmed down set of test cases based off of what we're trying to achieve in the model. If, for example, we want to start to, scale up that testing, that's very easy. I've set up a different profile here, and this has created 47 parts and therefore 47 automation test cases that are ready to now be executed from within the tool itself. Now, once we've actually created and run those test cases, we've had a look at the results. That's all fine. We see that we've run. That's great. But now something's changed. It could be a few sort of things that change. There could be something in your automation code that has changed, or it could be something in the actual business logic that has changed. If it's something that's in the business logic, we can just basically come through and update this model with anything that we need to update it with. So say, for example, instead of, click add to cart, there is another button in here where we have to say, switch tab or something like that. We can basically come through, imitate or explain that change, that change request on your model, hit save, and then once you save, that change is perpetuated and replicated, I guess, all the way across your workspace. So now, if I go to just refresh my end-to-end model, and in that model, you will now see that we've considered that change from the sizing and quantity flow. So if I expand this, you'll see that now that block has been added, and essentially that means that you can just keep this one asset up to date, and then all of your test cases and all of your test automation can be updated accordingly. And basically what I would do now is come through to the test generation tab, select whichever coverage profile that I want, and then go away and hit generate. And then that will go away, generate some parts. That might take a minute or so, and give you, an updated set of test cases for your model. Now, the other thing that I mentioned there was the ability to update automation code and sort of sync that with an automation library that you've got. So what I've just done previously is I've actually pulled down the automation framework that this model is running on. So it is a Java Selenium framework. I've just sort of cloned it from the Git repository. And inside here, I'm actually looking at the code snippets that we're using to drive our model. So what I can do here is, okay, well, if let's say we have a team of automation engineers who are responsible for maintaining the frameworks, the classes, and the functions that you use for your automation, that person can come in here, they can create, this is a code change, for example. What we can do is, what that person would do in this instance is then go to, I've got GitHub desktop here. I can basically push that up into my Git repository. And then what we can do is actually ingest that change directly into Test Modeler and directly into your models. So if I come out and go to the main menus, I'll just pick up projects, Test Guild webinar. And then essentially under here, we have a little button that's going to go away and actually scan and pull in those changes that we made inside of that automation, inside of my IDE in this instance. So I made a change to this add cookie function. Now, if we go back, go into the components, back into the actions folder, web general, and have a look at add cookie, you'll see now on line 4, that code change has now been synchronized into your application. And now that gives you the ability to say, okay, well, now I've done that, I just want to come through, go back to my scenarios, hit run, and go away and then rerun those test cases and regenerate that automation based off of that change that you've just made to your application. So hopefully that gave you a good overview of kind of how the things that Rich was talking about can be put into action inside of our tool. So we've covered quite a lot in quite a short amount of time. But I guess just to recap, we've sort of talked about how we can consider business rules and build out models that replicate the real application and put them into some kind of visual diagram. Then we've talked about how we can overlay test data and test automation onto those models. Then we've talked about how we can generate test cases based off of a range of different coverage settings. Essentially, now that becomes kind of risk-based testing. Actually, sorry, one thing that I think we didn't show was the ability then, when you're creating these coverage profiles, to actually target the test case generation. So inside here, what I've done is, so this is the coverage profile. And I've actually added a tag onto each one of my subflows to basically say, okay, well, how much do I care about testing this subflow? In this instance, what I've done is I've actually excluded the sign-up process from the test cases that we've created. And really what we're doing actually is we're focusing more on the checkout flow, whereas login, women products, we care less about, and sizing, for example, we've set to high. So that allows you to, well, once you apply that coverage, this coverage profile, your end result is a set of tests that focuses in on the areas that you really care about. So as Rich was saying, if you've got one component that is much higher risk, in this instance, a checkout process is probably higher risk than the login process, because we're obviously dealing with people's money. So it might make more sense to set a higher coverage tag to that, so that when we're going through and we're creating the parts, we're actually focusing in much more on that checkout process. So that's the risk-based testing aspect. And then we've talked about then how to deal with change and sort of change management. And then the nice final step there, which is also to then look at your test cases, see, for example, what failed, the messages that we get, but then also the nice green button that we all like to see when we're running automation, to see that this is run and we've got, a nice kind of thank you for your purchase there. Okay, so yeah, that kind of covers off the demo. Joe, I think we're on to sort of any questions.
Yeah, let's get to the questions. Right? Great demo. Thank you for that. So let's just jump to the questions. We have a limited amount of time. And the first question is, and can you stop sharing your screen? Perfect. How do you introduce modeling to traditional Selenium page object automation teams winning hearts and minds?
Do you want to take that, Rich?
That's an interesting question. Winning hearts and minds. It really feeds into the software entropy, right? I think to me, and the Selenium framework bit is neither here nor there in terms of. I think if you're not conscious of your test approach and the entropy of change, regardless of whatever you're trying to do in automation, you're going to struggle unless you've got the simplest system ever, right? And I think starting somewhere, and maybe targeting. If you're Selenium based and you're majoring on the UI at this point in time, maybe targeting some kind of early API strangling for an interface that's a real pain in the bum. It will start to get you some real good PR, right? The reason I say that is people know that there's a challenge. API testing is quick. It tends to be really stable. Yes, there's a bit of a learning curve, but once you got over that, it's quite easy to then implement. It feeds into any aspirations around CI pipelines, for example. This is the fact that you're going to get these problems in the first place suggests that there's some challenges in the way you're approaching it, right? And these are the kind of the steps that I would personally take and have taken. Let's be honest, to kind of win hearts and minds, right? I would suggest. To me, the problem is not a test automation problem, right? There's something far more fundamental, and that's really what I'm trying to kind of bring out.
Absolutely makes sense. Well, 1 second. So the next question is, can you elaborate how one can model a gray box testing approach on a rules engine?
So by that, I'm assuming what we're talking about is we've got a black box and we want to make it a bit more known. And so I mentioned the strangler pattern, okay? And therefore, this is something that I will know firsthand. And if you know me and you know where I've worked, you'll know exactly the examples that I'm talking about, in that inevitably you will have some technical debt within your organization that you don't understand, right? And there's a technical element of this, and there's a cultural and a human element of this. And the first part of it is raising the risk and understanding of the fact that you don't know certain things about an application, right? A black box that is causing you some problems, right? Or is making, by that I mean it's going wrong or it's causing you to be slow, right? And therefore there was a Three Amigos conscious decision to know something more about that black box, right? To make it a bit grayer, I think is kind of the terminology that's being used. And therefore, this is to create a wireframe to get started, get the SMEs in a room. And I think, interestingly, when those SMEs start to visualize how they think the system works, actually, they'll very quickly realize they don't have a common understanding of how it works. And actually, they've missed certain bits. I mean, it's quite interesting, right? I think when you've done modeling, there's a light bulb moment, right? And that's exactly the light bulb moment that your SMEs who think they know the systems, but actually, our brains are only so big, right? That's the light bulb moment that you'll get. And, modeling becomes the de facto way that we need to understand our systems.
It's such a learning process, actually, as you're building a model on a new system that you might not understand. 9 times out of 10, the first attempt at it is actually that's not right. There's another rule that I haven't considered, or if this, then it means something else than what I've written down. So actually being able to sit there, as you said, Rich, like in a room looking at a big screen and modeling out things together, it's such an important learning activity and sort of builds that knowledge of your application. Yeah.
So maybe this is a problem. The company I used to work for, they wouldn't want a bunch of people in a room hashing it out, spending hours. They would want it. They would say they didn't trust the model if people did that from scratch because they didn't understand enough of the systems because they were too complicated. Is this an all manual process, or do you have sniffers in production that can help create these models for you, or at least get you started?
Absolutely. I mean, there's I didn't really show the importers that we have, but typically with modeling that you never really start from scratch. In our case, there's always some kind of resource out there that contains those business rules that you can use to import and get started with. Whether that's like a rich text import or I don't know, people might have old BPMN diagrams from 10 years ago that no one's looked at for years, but they actually contain some of the business rules as well. So there's loads of ways to get started. Yeah.
I think just to expand on that again, and a little plug for the kind of modeler is two things. It's a modeling capability, but also it's got a very strong test data and data engine as well. And I think most of the kind of the tech debt that exists within organizations tends to do with kind of flows of data within systems and understanding business rules and systems. And therefore, we do a lot, not just around kind of the traditional test data stuff, but around profiling, understanding unknown data sets and kind of coming up with patterns around how we think they should work. So that, yes, absolutely, there's accelerators there.
Great. Okay, next question is, how do you change your way of thinking from traditional scripting, even if modular or page action-oriented, to using models and components in a model? I think, Judge, you alluded to this, how it takes a while maybe to teams to get used to this type of thinking.
Mhm. Yeah, it's a good question. I mean, it typically, for a team that has only ever done unscripting, it is obviously a mindset shift. But I don't think it's too much of a difficult shift if you spend 2 or 3 weeks starting to build the modeling knowledge from the ground up. Because I mean, typically what I see is that when you start showing people how to model particular scenarios, then they automatically start thinking about, oh, well, I can apply what I've done there to my really complex API that I've got somewhere else, or my super complex UI scripts that I've got. So it's definitely a process, but yeah, it becomes very, very intuitive, just because it is obviously that visual kind of approach, I think.
Kind of running out of time, but I want to get to as many questions as possible. Please tell us more about the methods of reduction of the combinatorial explosion effect. How scalable is this approach?
So this is really talking to the optimization capabilities built into Modeler. So I'll defer to George on that one.
Yeah, yeah. So I mean, I showed it briefly, but it's all about kind of that coverage section that I showed, and being able to define what you actually care about for testing, because it's impossible to create tests that test your entire system perfectly. You have to tailor it to what you really care about the most, and that's where we have the process of tagging bits of your application on the screen and saying, okay, I care about component A more or component B more, and then being able to generate the minimum number of tests that satisfies that condition that you set up, so that then you don't get that explosion where you get 5,000 test cases for an e-commerce website. You actually only get 17, 18, 19 that are really sort of doing the heavy lifting, and not ending up with 100 tests that are just doing basically the same thing but clicking one different button at a time. There's not, what's the added value in that? I don't think there's too much.
Yep. So maybe we go into a lightning round. While we're doing the lightning round, if you folks need to leave, just head on over to the poll before you do. We really appreciate you just answering 2 quick questions. All right. What types of coverage are used? Statements, condition?
So in terms of how we set up our coverage, it is based off of what you see in the model. So there's a number of different settings that will basically look at the different combinations of behavior that you've added onto your model. So it will be about sort of, we call them in and out combinations. So if you've got 2 fields interacting with each other, how can we cover the different combinations of behavior that exist between those 2 fields? So there's loads of different ways, but I think that kind of covers the main.
Does this work with JavaScript code?
Absolutely. Yeah, it's all template driven. So whatever code you want, if you wanted to, you could literally create rich text from from Test Modeler.
Do you use Test Modeler to test Test Modeler?
We do.
How does this work with Gherkin? There's a few questions on BDD. Is this the same as BDD? Can it work with BDD?
Yeah, so I mean, any of the blocks that you saw on the screen can be given the Gherkin language. So on those models, you would overlay your given, when, then, et cetera, and then the output is your Gherkin feature files, along with any of the Cucumber-based codes that you need as well.
Probably time for one last question. I want to respect everyone's time. So how do people get started? First off, you can go to the Learn More tab and definitely check out Curiosity. I'll do the plug for you all, but is there anything else people can do to get started?
Yeah, so we've got, in terms of if you want to start a free trial, you can head over to our website. You'll get a 2-week trial just ready to go with Test Modeler. There's loads of really good tutorials as well. You'll probably see my face or Rich's face on some of those tutorials. But we'll follow up with all of the best places to get started as well.
Excellent, excellent. All right, guys, I want to thank you both and Curiosity for doing this free training. Like I said, it's a really interesting topic. I know there's a lot of interest in. So thank you so much for joining the guild. Before we go, any parting words of wisdom?
Get
Keep
started.
testing.
Love it. Awesome.
Yeah,
Thanks again.
Thanks very much, Joe, for having us on.
Anytime. Appreciate y'all. Thank you so much. Cheers.
Yeah, thanks a lot.
Thanks.
Thanks, everyone. Bye-bye.